Isha is one of our scholarship students. Okay, the thing is, in the past years, consistently our scholarship students have secured single-digit rank on subsequent gate exams. Okay, so Isha Chaudhary is this year candidate, and she was actually missing last month's class, and I came to know that that was because she did an internship at AMTZ. Okay, I thought her experience will be useful for many other students, biomedical students. So I asked her if she could share her experience, okay, her learnings and takeaways. Okay, so that's a point of this discussion, and let's give the stage to Isha Chaudhary. Okay, over to you, Isha.
Thank you so much, sir. So, hello everyone. I am Isha Subhash Chaudhary. I am in my final year of BTech Biomedical Engineering. I live in Nagpur, Maharashtra, and I would like to share you my learning and takeaways from the internship experiences that I have had. Okay. So the recent one that I had done as my internship was at AMTZ. It is Andhra Pradesh MedTech Zone. It is one of the largest medical technology manufacturing clusters. It has 150 companies in that zone established, and more than 200 startups are incubated there. I saw that there were two incubation centers. One was Medi Valley and another Bio Valley. And I found this environment. The whole environment was very much full of brotherhood and very much like they promoted biomedical and the medical zone, and it was a really good experience. This place actually gained a lot of um, what we can say spike during the COVID, and they were big contributors in Make in India, and they made PPE kits available in the COVID duration, which was actually being important. Also, they were supplying around 2,000 oxygen concentrators at that time. So it's a really proud moment for us that we have such a place. It's based in Vizag, and the internship I did here was not actually a internship at a company that are there, but actually a training program that they have as their in their curriculum. This is by in IBSC, which is Indian Biomedical Skill Consortium. So this is the one program that I chose, industrial training program on biomedical equipment troubleshooting and maintenance. So there were three levels. Level one being critical care equipments, level two OT equipments that are operation theater equipments, and level three radiology. Um, I have provided the link here. We'll try to visit the website. Just a second. Is my screen visible now?
Yes,
Trying to share the website.
the website is visible.
Yes. So on this website, you can go to courses, and actually there are many courses, but my friends and I chose this one as this was very reasonable, and they were providing medical device hands-on training, which was very interesting to us. And also we had 1 month time in our hand. No, this isn't the one. Yes, industrial intern training and internship. Yes, this one. So there are details here that this is 1 month duration of training program. The timing was 10 a.m. to 6 p.m. and This was the course fee, and I would suggest that you all um, go there as a group. You can have a group of students from your batch, or maybe even including your juniors, because I found that really helpful, that we were a group of people, so we could ask for more and more things as a group, and it's just very easier to be in a different state with friends. There are accommodation facilities too, and there is additional cost for that. Um, this mobile number is probably of Durga Ankita ma'am's, and she's really very helpful. You can contact her anytime, and she will. And I urge you to take all the details if you happen to take up in this internship. Just ask her everything, because you will be going for a training program, and you should be knowing what all will be taught to you. So we were yes, most of these were included, and also there were plenty of things that we learned. So these are the um critical care equipments. OT light to this much is surgical and anesthesia workstation, and yeah, this will also be in surgical. So OT equipments, and this is radiology equipments, and we had multiple site visits too. So let's continue with our PPT. Another internship, or to say it's more like a training program that I did after my second year, was in Horiba, Nagpur. Even they provided, Horiba India Technical Institute provided their own such a training program for the students. So we visited there, and we learned how to dismantle, like we learned hands on their CBC machines, how to like their principles, and the scheme, how to basically install their machines, the basic model only, but how to do it by looking at the schematics. um, so the one thing is that any internship, any training program you do, just be attentive to what they are saying and ask as many questions as you want to. Don't ever feel that you are you will be laughed at or anything, because as a biomedical engineer it is very irresponsible to not ask questions, because any even a small doubt can lead to a catastrophic event, and it's very important that you ask questions. And I would say, even I had paid for the training programs, but even if it's not paid and you are a intern there, try to ask as many good questions as you can, and um, make connections, and also don't be in your own group. Like maybe you are with your peers, try to connect to those who are of different colleges and try to know their experiences, so that you know more about the industry. And I would say take business cards or LinkedIn email, or the even better contact number of anyone you find you will be able to have a chat for later future, because you never know, you might need someone's contact in the future as a biomedical engineer. So the different roles for biomedical engineer that I have seen have been quality assurance, quality control, and in the refurbishment area, where this was where I saw this at Horiba, and there was a refurbishment area where my senior was working, and all the machines would be there, which are for repair. And even there was a QA section and QC section, and the medical devices had to be um, checked and calibrated to the according to the standards. You can take up teaching after your higher studies, and doing MTech or MS is for sure very great in this field. But as I've uh, seen that it's not just MTech in biomedical engineering. There might be many colleges that have MTech in tissue engineering, MTech in only medical imaging, MTech in biomaterials. So these are also the streams that you can go forward in. So make sure you research about that too. Um, you can be take up a service based or product based businesses as your future long term goal. Service based business being like there the ones I know are being a distributor for different companies in your city. As you are the native there, you would be knowing the hospitals that would be buying their machines. So you can be a distributor, service provider, or you can even be a third party maintenance service provider. And of course, product based businesses being having a franchisee maybe, or importing some devices, or having your own medical manufacturing unit. Now entrepreneur and innovator is something that really is inspired me to be a biomedical engineer, and we would talk about it in the next slides. Um, there is a lot of scope to be an innovator for us, because there are so many plenty of problem statements. And one of the faculty at AMTZ actually urged us to not only focused in the tier 1 cities, like most of us are in tier 1 cities, but he told the scenario that even um, that in India there are many places in the peripheries uh, that have really bad conditions in the medical technology, and we should really focus on those spaces, and they have a really good scope. Another opportunity is research and development. You can do it as an innovator or in some company itself. There are hospital biomedical engineers. So the task of a hospital biomedical engineer, as far as I know, is that one hospital has maximum of 3 to 4 biomedical engineer at max, and they have to take care of the maintenance of about 1,000 or 2,000 machines as an individual there. And if there is a problem in the machine, they get a call, or they have an application, they get a message, and they have to attend to it in 30 minutes. They only have to attend to it in 30, take their time to actually bring the machine back to normal. Now application specialist is also a very important job, and this is they have to there is one application specialist, mostly for a state or from a company, who manages the his role. The role of an application specialist is that he or she has to tell all the technical aspects and the working of the equipment to the hospital medical staff, because they don't know how the machine operates. So they are the ones who after installation, um, who teach the medical staff at the hospitals how the machine has to be operated. So this requires a good level of communication, patience, and also a lot of technical knowledge. Also, um, Another job is service engineers that I already knew. This was the only job I knew before. So this is basically you have to go and perform from a company. There are service engineers that I have to that are for a region, and they have to go to the to the site where the machine has maybe has some problem and it's not working, and they have to make sure that it is working to how it should be. Now, there is regulatory affairs. As we know, medical devices are very important ones, and there are plenty of regulations and standards set for it. The regulatory affairs job is so that they have to ensure that the medical device itself is working according to standards. The manufacturing unit is following the standards, and even from from the start of the product cycle to the end of the product cycle, they are following the standards as set by the regulatory body. That's the job of regulatory affairs. Now, sales engineer is a job that's there's a myth that this is not a technical job, but sales engineer job is a very much technical job, as it's not just selling of some pens or normal stationary stuff. It's actually 1 to 1.5 cr mri machines that you would be selling to one hospital chain. So it's a very important job, and a sales engineer needs to know the whole technicality of um, a machine, and has to explain those to the buyers. That would not just be random people, but doctors and maybe the biomedical engineers at the hospitals. So let's have a fun activity now. um, I would like you to share me some of the skills that are in your CV so that we can actually learn from each other. Like, what are more skill sets that we can learn as a biomedical engineer together? So, may I have someone to talk about maybe some just in a few words? Like, one of the skill I shared is microcontrollers. Is there someone who can speak up? Hello.
Yeah, I would like to speak up, but let's give a chance to others. So this is how it feels when feels in class when you don't get a response. Okay, but anyways, we just need to give them time, and they will certainly respond. Okay.
Yeah. The speaker. Hello.
Niranjana, go ahead. Niranjana, yeah.
Sir, by I have went to an IV for an industrial visit to Cyrix Healthcare. So they I got a lot of knowledge about ultrasound. So we went there and we got a lot of knowledge about it, like how much of UV rays it passes. And I have taken scan also, sir. So I have a quite knowledge about it. Not a lot of, but somehow, somewhat. I can take somewhat a scan of like from wherever in the body parts. So I have small knowledge about it. So
So we can write this as um, using medical devices and being up to date to the medical device working. So, anyone else? I would write a few. You can also learn MATLAB. This And actually, all the subjects that are taught to you in your biomedical course in your college, you should go through the syllabus, because if you are sitting for placements, they would be checking your syllabus. Go through it and make sure you have the knowledge of what you have learned in your previous semesters, because you might forget it, but make sure you do that. So MATLAB was taught to us. You must know electronics and electronics and electrical concepts basics too. Like you should be able to recognize different electronic devices. Yes, Mayakandan, please.
If you don't mind, can I share my experience or something?
Yes, sure.
Um, yeah, I have a knowledge of. I mean, we have a workshop on MATLAB, so I have learned how to use the MATLAB as a basic level, but I didn't get a didn't get a full experience on that. But we have worked on something, and then there is one another software called Proteus or a multisim kind of software, which is used for designing PCB designs virtually. So you cannot, I mean, you don't need to assemble the components in the real time. You can just connect it in the software, and we can uh, see the output through the software. Even we can print the 3D form and another information with that software. And I hope all biomedical engineers are know about the 3D printing.
Yeah,
Um,
true.
re- Recently, I have an uh, NPTEL course called Biomechanics. It should be very useful where we can study about the human body joint, I mean bones, joints mechanics, and the muscles which are connected to the bones, like tendons, something like
Hmm.
lot. But the calculation, when we come to 2D, the calculation will be easy. But we are come to 3D, the calculation is more difficult. So integrating with that the 3D implants, it should be very useful. And my in my college, our staffs are some kind of staffs are there. They're telling that it should be a very small researchers in this field. So you can try this also. Like then I have some experience on it is already there in second topic. The medical devices. I have attended some training where we can. They told me how to use that. Uh, I mean, how to use how where are the parts, like a lot of information. But still now I don't have a much experience on the medical equipments, because in my course curriculum this semester I have a medical, I mean hospital training. So I have to learn a lot. That's all I think I have to share.
Okay,
Uh,
thank you. Sir, are there any chats I am unable to read them?
Can you repeat that? Sorry, I couldn't hear that.
Are there any chats? I am unable to see the chats, which is why I'm asking.
Charts, is it? No, I don't see any charts either. Chat, is it? Okay, okay.
Chats.
Sorry. 1 second. Okay, now, yeah, there are so a couple of, in fact, many comments in the chat. Uh, Anaconda Navigator, fine. Biomechanics, medical imaging. Can we tell you something about application of MATLAB in our field? You can code it in MATLAB or like Cancer Cell. Okay, it's like, okay, they are discussing some applications of coding MATLAB. Then, okay, say for example, image processing and all that, you would need MATLAB, right? And then signal image processing, yeah. Okay, then someone has mentioned lab view, I suppose.
Hmm.
Yeah, So these are Anaconda is, any of you is wondering, I suppose, Docker, Anaconda, this is, if you're using Python and if you're using multiple versions, typically you want something like Anaconda to keep track of things, okay? So AutoCAD can also, I suppose that's Anaconda that you're referring to. Okay, AutoCAD can also be used for designing. Yeah, see, okay, this is all good, but because this conversation, showed up, let me also add a few roles that I know, okay? In fact, if you show the previous slide, many roles are mentioned, okay? Importantly, so there are also design engineering roles. Any device that you have, some engineer is going to design that, right? For example, use of AutoCAD, use of PCB, right? Even sometimes you'll be using MATLAB in some design and simulations. Design engineering is an important thing, okay? And then you have manufacturing also needs a lot of engineers, okay? Some examples: PCB design. You want to design a PCB, again, that would require an engineer. You want to 3D print something, you want to like fabricate a plastic pot or something like that, mold or something like that, again you would need an engineer, okay? So many of this involve a lot of engineering skills that many of you have mentioned. um, the be it typically some simulation type software or some visualization 3D technologies. And these many of these, whatever you're mentioning, they are also getting automated, in the sense that coding, you know uh, coding can mostly be automated, but what is required is the knowledge to know what to automate, right? What to tell the computer to automate. So that, from a Gen A perspective, again, data science and electronics, you want to be careful. If you're really good at it, get into it, because there is a specialized department in data science, specialized department in electronics, electrical engineering. So unless you are really interested in it and you have spent a lot of time acquiring the skills so that you can put up a good competitive, you have a competitive edge in a job market, that is something that you want to carefully address it. So there is design, there is manufacturing, there are also management roles, which many students miss. There are hospital management roles. Then there are also any company that you need, eventually need managers, okay? It's CEO, CTO, just manager, okay? A lot of management roles, even for marketing, sales, there are a lot of management roles. Any device, you mentioned regulatory affairs, survey, regulate, this partly aligns with the, R&D, entrepreneur, innovator, and then regulatory affairs. There is a lot of engineering work involving safety and testing safety of any device that you make. Testing is, you need a lot of equipment, you need a lot of expertise doing that. And I suppose someone mentioned they learn to use ultrasound, right? Not ultraviolet, right? UV, right? I suppose it's ultrasound. I also, because that suggestion came, there are also roles that there are licensed, certified roles for, say, echocardiography, where you are not necessarily a doctor, but the doctor doesn't have the time, but to do certain things a doctor cannot afford to do. Okay, he's spending his time elsewhere. Okay, in a ICU or a critical care unit or something like that. At that time, okay, he's occupied with something like that. There is an echo technician, which needs a lot of skill and knowledge of anatomy, the mission, and all of that. So there are also certified license programs on that. Okay, many students do not know about that. And in general, this is something that I always tell students. See, in fact, this is something that many of my family members used to ask me. So, what is a mechanic? I have done civil engineering, I have done mechanical engineering. Hey, that masonry can build a building. What can you do? That mechanic can repair your bike. What can you do? Right. So, this is a very typical question, right? The main difference is, acknowledging this is very important. A mechanic can at best repair one bike or one machine at a time. yeah, a design engineer can design a new machine that can be literally fabricated, produced thousands or hundreds or thousands and lakhs and millions of times, right? So the scale at which they are working are very very different. Mechanic is um, one at a time. Engineer can create something new, can be mass produced and have an effect at a very different scale. That difference need to be acknowledged. Okay, so again, this will mostly align with say R&D, entrepreneurship, innovator. Okay, you are a design engineer and all of that. And yeah, you mentioned something about. I'll let you continue. Okay, I know this is because you asked the question, you invited participation, right?
Yeah.
That's actually very correct. The comment about accessibility, affordability, that's very very correct. For example, hey, there are MRI machines, but at a rural place there is frequent power cuts. So you cannot use that MRI machine at a rural place. So you need a MRI machine that is power cut proof, typically using something like solar or something like that. Or you have an MRI machine, but this is again a rural place, a daily wage worker who cannot actually show up at the scanning center. He cannot afford to take a day off, right? That time the MRI machine needs to go to that person for real accessibility, affordability. Can it be put in a van, right? Can it be made mobile? So these are some interesting questions that are already being addressed. Okay, and engineers, design engineers, innovators, entrepreneurs have a lot of scope. So, problems are like innumerable. So there is a lot of scope. Okay. Okay. With that, sorry, Isha. So I'll let you
No
continue.
problem, sir. Okay, so we had a very good discussion on the skill sets. The basic was that you have to learn passionately and the avenues will open up. Let's move on to next slide. The skill set, I actually met up with a scientist there who had his own startup. So he was actually so learned, like he had so much of knowledge. And even he told me that you should know something about everything, and only then be able to find out the best solution for any problem. And this is what I wanted to share. Another thing is one of the peers, not peers, like one of my connections told me to start pitching as a student itself, because you will get more funding if you want to be an innovator, entrepreneur. And even if it's a small project, you should start it because you will require it, and you will know how you have to present your say your idea or prototype. One important thing is you should always get a patent and protect it as your IP. You can also, one thing is that whenever you start with a problem statement, you should check with the patent website that if you should check in the patent website if that solution is already available. These are the websites where you can check. There are ways to check. You can see YouTube videos on how to check if what all patent ideas have already been done on the problem statement, or if the idea that you have thought of has been already patented. So see to it and try to make a better solution. So for the same problem statement, you can maybe miniaturize the all existing device, or think of a very new way with improved outputs. Now these are some things that I didn't know, but I learned at AMTZ that CDSCO is the regulatory authority for medical devices in India. And MDR 2017, which is Medical Device Rules, is a regulatory framework for medical devices, and it has everything from the licensing required for import, export, or for even manufacturing, for the place where we can perform even radiological uh, um, even radiological devices like MRI. They require a licensing for the place, like they require approval from the AERB, which is a regulatory body for radiation. They are needed to approve that the place is correct for the usage of MRI machine. And this MDR 2017 has all the details. It has all the forms to be filled up for getting licensing, registrations, and sales, distribution. All the regulations on the standards are in it. But in real world scenario, if you have a device and you have to get licensing, you wouldn't read the MDR 2017 because it's very vast. You would actually approach a consultancy, and they would do all the licensing and checking and all the processing for you. And your medical device should be in compliance to MDR 2017, and it is mandatory in the Indian medical device market. Now, this is the classification of medical device according to standard IEC 60601-1. This was actually the initial first class that we had at IBSC AMTZ. So they taught us there are three classes: class 1, class 2, and IP class, which is internal power supply. The class 1 is for protective. The class 1 is actually highly protected, and it has a reference ground 2. So it has a 3-pin, and you can find this or this symbol on a device to know that this is a class 1 device. And this symbol is for double insulation, and this would be found on a device that is um, given a class 2 by our regulatory body. Um, so these are very important symbols that would be found in every medical device. That medical device has to be classified into class 1, class 2, or class 3. Now, along with classes, we were also taught types of medical devices. There are 6 types of medical devices. Type B is these are the symbols. This is just the body. So this is type B body. This is the second one is type body floating, BF. Type CF is for the cardiac, and these will go through later. So type B of a medical device is a device no uh, which has no contact with the patient, or if it has a contact, the contact is non-conductive. So this can be hospital beds. It has a contact with the patient, but the contact is not conductive. It's a non-metal contact. So the hospital beds, even ventilators are type B because the contact is not metallic. Now in the type BF, there is contact, and the material is conducting, but there is no cardiac interference. So The examples can be pulse oximeter, and you can also have MRI as type BF. If it's no, just a second. Ultrasound can be a type BF only if it's taking the abdominal um, um, if it's doing abdominal imaging, it's type BF. But if ultrasound is taking the cardiac imaging, it would be under type CF because it has cardiac interference. So this is the difference between the three types. Now I'll explain you about this defibrillation proof. These look similar, but these have some these symbols around it. This is actually that it is defibrillation protected. Uh, you might have seen defibrillator in the movies where it it is used at the time of cardiac ventricular fibrillation, where the person has very high rate over 200 bpm, and it aims to convert dysrhythmia to normal sinus rhythm. So, whenever this situation occurs, uh, it's a very sudden situation, and therefore, and there would be a shock sent over 200 joules of shock to the patient. So, the and being a sudden situation, the doctor won't have time to remove the conducting machines that are on the patient, like the ECG or any other machines. So these machines have to be provided some isolation and protection, because because there would be a flow of charge from the patient to the connected devices, and the patient can be harmed, and from the backflow, and even the device can burn up. The doctors can be affected, which is why the devices like ECG are mainly defibrillation protected, and they would have this symbol because ECG has cardiac function interference, so it would be CF with defibrillation protection. If it is CF, only type CF, it would not be used in ICUs, it would only be in general wards, because defibrillation protection is required when if a patient goes into a situation there where he might need a defibrillator shock, which is more mainly in ICUs. Another classification type, uh, there was class 1, 2, and IP. So there is a risk based classification too, which is very usually used. And this was the doubt that I asked to my faculty, that I haven't heard of class 1, class 2, and class IP. I have heard of class A, B, C, D. Also, there are many classes. There are many classifications in different according to different countries. I am only pertaining to Indian ones. So, medical devices risk based classification is class A, class B, class C, and class D. So, class A devices are low risk, class B devices are low to moderate risk, class C devices are moderate to high risk, class D devices are high risk. Now, this risk is in accordance to the impact it could have in the environment or to the patient. In the case of a catastrophic event of a machine, in case the machine doesn't work according to its functioning, how much risk will it be to the environment or to the patient himself? So this is how they are classified, with the highest risk of class D. So these are the examples. As you can see, cotton swab, wools, dressing, surgical dressing, these are in low risk, and guide wire, heart valve, even the pacemaker would be in high risk. Um, while applying for a medical device approval and getting a license for a medical device, you will have to specify the class according to these, as this was mentioned in the MDR 2017. This is all that I would like to share with you today. Thank you. If you have any doubts, you can ask me now.
Anyone has questions? Once. I actually forgot to say this. This is not a sponsored video and all that. She had this experience. I thought it would be useful. In general, see, I know many students do their final year project by, they go to a project center, get it done. Okay. So that is not recommended, that is not suggested. But instead, even if it costs, if you have to pay some money, experience like this, okay, is very, very useful. Okay. You need to know ground reality, and networking best happens face to face. So, you need to, it's a good experience visiting these places. If not conferences, exhibitions, or things like that, product exhibitions and things like that, at least, students should go, find a month. That month will be very, very useful. In fact, if you can plan a month during your summer holiday or something like that, during third year, something like that, okay, if you know it beforehand, you can plan for it. Okay, this is suggested. And thanks a lot, Isha. This was again, this certainly is useful. You also brought on many important details. Some of the logos, I, I have spent time on an ICU, but I have not necessarily noticed. Okay, so some of these details, even I got to learn a thing or two in today from what you presented. Okay, and okay, someone asked for the website, you shared that. Hey, okay, and let me also say this: there is one more important engineering role that is hardly that's not recognized. Okay, and often there is also a lot of issues associated with that role. You guys mentioned MATLAB. You could use MATLAB for image processing. You could use MATLAB for signal processing, filters, and things like that, right? You could you could use MATLAB for many other MATLAB and similar any coding platform, any coding language, Python, for many other things. For example, she mentioned ventricular fibrillation, right? So what is ventricular fibrillation? Can you actually simulate it and show either the signal or the underlying physiology at different time scales? Okay, so this kind of, can you, if there is a car, if there is a, to give you a simple analogy, if there is a ball in a projectile motion, you could calculate its speed and position quite accurately, right? Now, can you do that not for a human body in projectile motion, but can you do that for a parts of the human body? For example, this electrical activity that is going on in the heart, right? These, in fact, there are also many engineers working on this. Okay, many device development and all of that. In fact, testing, safety are all based on simulations. Typically, finite element analysis, but there are also other means to finite elements if it's solids. Okay, you could also do some finite volume or a combination based analysis. Okay, so you could simulate things, and this role is also very important, and this role is also there. And regarding, the challenge regarding some of the roles that I mentioned, design, manufacturing, so simulation and all that, this is this is only starting to mushroom. Okay, it is starting to bloom. These roles are starting to appear in our country. Okay, and so far service roles dominates, but that scenario is changing, and you guys need to be aware, and you guys need to have a good vision so that you know uh, we reach the change faster. Okay, that is one thing. And the role that uh, hardly anyone knows is the closest word that I came for that is called inner engineering. Okay, so when my friend mentioned inner engineering, I thought whether this is like Haynes or jockey. Okay, so that is the quick comment that I had. But the point is, any of the roles we are discussing, engineering and scientist roles, or from a treatment or treatment perspective, or from a diagnosis perspective. This is not from a prevention perspective. Okay? Because that's one of the hardest things. Okay, but that role is also there. Okay, and in fact there are many good works on that. Uh, so ventricular fibrillation we mentioned, right? So I have simulated, for example, ventricular fibrillation on a beating heart. Okay, so this is like a virtual 3D heart, at least parts of the heart, and it's mechanically pumping, and many things that you could measure. If it were an engine, what's the output? What's the temperature? What's the efficiency? Many of those things you could actually get it from the virtual model that I have. This is not like some VFX graphics. Okay, so I have simulated heart, I have modeled blood, I have modeled even bone. Okay, at least have some publications to back on it. But this role is there. So this inner engineering, okay, this is already taking. But let's say physiological engineering. Okay, what you could do to prevent diseases, right? Often the body heals itself, and the primary role of a doctor is to support the body heal. Okay, establish conditions, nurture the body to heal, but it heals itself. What is this physiology behind it? Okay, there is also, of course, a lot of work going on in genetics, things like that. But if you ask me, that is still at its infancy. Okay, so that role is also there, which hardly anyone recognizes. Okay, so with that, we have other comments here. Okay, so you have some suggestions on website links and things like that, and I hope this was useful. This was a useful discussion, right? This awareness needs to be there. Real world exposure needs to happen. Okay, so regarding patents, so this year we have Isha presenting, right? In 2021, 2021, after 2021 exam, Abhishek Soni made a presentation on how to patent. He did patent, and he did come and share his experience. Okay, he did patent by working along with his professors at his college. So what is the process, logistics details, all of that, and more importantly, how can domain knowledge help you with patent ideas? It's not about like you need to know what's going on in the field, on the ground. Okay, in a ICU, how that domain knowledge converted into your patent and things like that. So we already had a webinar like that. In fact, I have publicly shared that session. Okay, you could go take a look at that if any of you are curious. Okay, and my idea is, ideally we want experts, leading scientists to come and share their experience, but they were also students sometime, right? It's not like they directly become experts or scientists, right? So that's how I see you all guys. You're all future leaders. That's my vision. Okay, that's also the reason to actually come and ask you to share your experiences. Okay, I feel this is certainly useful. Today's session was useful, and as and when I find something that is relevant and appropriate, we will certainly arrange for it. Okay, so let's again thank Isha for the wonderful session. And okay, so one question is, learning software like CST Studio, CAD, SolidWorks is important for biomedical. Yes, it depends on the role. If you're in design, manufacturing, simulation, testing, and all that, these softwares are very useful. Okay, so it depends on the role, and yeah, there are many jobs available if you know those skills very well. Okay, great. So that brings us to the end of our scheduled time. So we'll meet again. Okay, have a good one, everyone. Take care. I'll see you again. And one last question, Isha, is it okay to publicly post this?
Yes, sir, sure.
Okay, in that sense, that's good. Let's stop here. Have a good one. Take care. I'll see you again tomorrow. Okay.
Okay.
Yeah. Bye, everyone. Take care.